to write this expression as a single logarithm, we're going to use three properties. One of the properties says that if you have a sum of logs, so for instance log of A plus log of B, that will turn into the log of a product. Log of the product of the arguments, A times B. If instead of a sum of logs you have a difference of logs, log of A minus the log of B, that will be the log of a quotient, A over B. And finally, if you have a coefficient on a logarithm, so n times log of A, the coefficient of the log becomes an exponent on the argument, A to the n power. So we'll use these three properties to combine everything in our original expression into a single logarithm. So the first thing I want to think about, just follow the order of operations, and I have a grouping, log base 5 of x plus log base 5 of y. I'll deal with that guy first. I'll have 1/2 times, that's a sum of logs, so I need the log of a product. This is log, still base 5, of the product xy, minus 2 log base 5 of x plus 1. The next thing I want to do is deal with the coefficients on my logarithms. Those are these guys. Anytime you have a coefficient on a log, it becomes an exponent on the argument. So the first part of this expression, log base 5 of xy, gets an exponent of 1/2, and then minus log base 5 of x plus 1, coefficient of 2 in front, becomes an exponent on the argument. Finally, I have a difference, a subtraction. So it's a difference of two different logs. And this will end up being the log, same base, of a quotient. Guy with a positive coefficient goes in the numerator, xy to the 1/2. And the guy with the negative coefficient goes to the denominator. It divides the argument. One other thing that you might do here is the exponent of 1/2 in the numerator could be thought of as a square root. This could be written as log base 5 of the square root of xy all over x plus 1 quantity squared.